Why is the zeroth law important for temperature scales? Have you ever wondered how we can measure temperature and compare it across different systems? The answer lies in a fundamental principle known as the Zeroth Law of Thermodynamics. This law is essential for understanding temperature scales and how we define temperature in a consistent way. The Zeroth Law states that, if two systems are each in thermal equilibrium with a third system, then those two systems are in thermal equilibrium with each other. This means that if System A and System B are both in balance with System C, they must share the same temperature. This concept is vital because it allows us to treat temperature as a property that can be measured and compared across different systems. Imagine using a thermometer. When you place it in a hot cup of coffee, the thermometer reaches thermal equilibrium with the coffee. According to the Zeroth Law, if the thermometer is in equilibrium with the coffee, and you later check the temperature of the room, you can confidently say that the thermometer will give you a reliable reading. This is because the thermometer acts as that third system, allowing us to assign a numerical value to the temperature of the coffee. Without the Zeroth Law, we would struggle to define temperature as a measurable quantity. If we could not confirm that two systems at the same temperature do not exchange heat, we would have no basis for creating temperature scales. The law makes temperature a transitive property. If System A equals System C in temperature, and System B equals System C, then System A must equal System B. This logical consistency is what allows scientists and engineers to develop reliable temperature measurement tools. Temperature scales like Celsius, Fahrenheit, and Kelvin relying on this law to ensure they are consistent and accurate. The Zeroth Law provides a foundation for understanding heat transfer and thermal processes, which are critical in various fields such as meteorology, medicine, and engineering. In practical terms, the Zeroth Law tells us that when two objects are at the same temperature, no heat will flow between them. This understanding is the basis for studying thermal energy exchange and developing standards for temperature measurement. So, the importance of the Zeroth Law in relation to temperature scales cannot be overstated. It defines thermal equilibrium, establishes temperature as a measurable quantity, justifies the use of thermometers, and enables the creation of consistent temperature scales. This principle is fundamental to thermodynamics and makes the concept of temperature accessible for both everyday use and scientific study.